Hello there and welcome. In this video, we will look at what class imbalance is, why is it bad, and what are some ways in which it can be rectified. So let's begin. First, let's understand what class imbalance actually is. Imagine you're building a smart treat box that would give out a dog treat every hour if the animal in front of it was a dog, and a cat treat if the animal in front of it was a cat. To do this, you would need to create a machine learning model that could identify cats and dogs. If your training data to build the model had 900 photos of dogs, but only 100 photos of cats, the model might learn to favor dogs. This skew in the data is what we call class imbalance, and if not properly rectified, can have a significant impact on model performance with real-life impact. For example, the deployment of this model would make your dog fat and your cat super hungry all the time. Now, like before, there are a few reasons why this data imbalance could happen. The first is that the process generating the data may be a non-Gaussian process, or a process that doesn't follow a normal distribution, which is a common assumption in many models. For example, you may have decided to collect the images using your treat box itself, and programmed it so that it would give both a cat and a dog treat every 30 minutes or so, and take an image at the same time. This seems like a prudent strategy. The only problem being, your dog quickly realized that there was a machine on the kitchen counter, giving out treats every few minutes. So it would go and stand there first, and the camera would take its picture. The result? More dog pictures than cat pictures. Another reason could be anomalous events, or in other words, rare, unusual, or unseen events that introduced unexpected patterns in data. Taking the treat box example again, maybe you decided to add a motion sensor and an LED flash to the box that took an image only when the motion sensor was activated. Again, a smart strategy that would save battery power, but unfortunately your dog, in the mood for fun, found the flashing LED and decided to dance around the box for 20 minutes. In this case too, all you would then find is pictures of dogs and little to no cat images. Another reason for class imbalance could be human error. For example, you, while transferring images from your edge device to your computer for building the model, might accidentally delete a big portion of the cat images. Hey, things happen in the real world. And then decided to still go forward with the project without taking more cat pictures. Well, your dataset would be imbalanced now. Fortunately, detecting class imbalance often involves a simple exploratory data analysis. You can check the count of instances per class, again using the pandas library. If one class significantly outnumbers another, you've got an imbalance. Let's talk about solutions now. There are a few ways to rectify this imbalance. The first is undersampling. This involves reducing the number of samples from the overrepresented class to match the minority class. Or, in other words, using the same number of dog images as there are cat images, and ignoring the others during model training. This strategy reduces your data size, and as we will see later, is not the best way to build models. The second strategy is oversampling. Opposite of undersampling, this method involves increasing the number of samples in the underrepresented class by duplicating them. Or, in other words, copy-pasting the cat images so that it equals the number of dog images. This strategy, while it doesn't reduce the dataset size, still isn't that great, as it reduces the variability in your data. To make your model robust and to get really good performance, ideally, the images should have different backgrounds and the cat in different poses in those backgrounds. Another innovative method to rectify imbalance is SMOTE, or Synthetic Minority Oversampling Technique. Implemented using the Imbalance Learn library in Python, it creates new synthetic samples rather than just duplicating existing ones, and is the preferred choice for class imbalance rectification when working with tabular data. Okay, so what do we do if the data is images? Well, you can use data augmentation techniques that we discussed a few videos earlier to create new cat image data. In summary, recognizing and correcting class imbalance is crucial for building fair and accurate machine learning models. Remember, good data leads to good models, so don't let imbalanced data ruin your models. Hope you found this explanation helpful. We will see how to detect and rectify class imbalance using Python when we build classification models. In the next video, let's explore data normalization. See you there.